Some of you guys were here last year, so some of you may know me. My name is Anna Shcherbinina. In social networks, I'm also known as Garchica. I've been working in the company Artec for the last 5 years as a web development team leader. Today, I'm going to tell you about our new feature called the body measurement, where we applied the use of Docker and the GPU. Okay, so my goal for today is to share with you where you can apply the use of Docker with GPU and where we did it. Also, how did the final solution looks like? What kind of, why did I use the Docker as an external DSL? And what difficulties we faced and how did we handle it? And finally, I'll share you how to access the GPU from inside the Docker container. Let me first tell you a little bit about my company and some fancy cases from our life. So, company Artec 3D produces the best handheld 3D scanners. We produce and manufacture high qualified but yet easy to use portable 3D scanners, 3D software, and we provide an SDK for easy integration. Right now, I'm going to share with you some interesting cases from our scanner usage. Take a look. The scanner spider was used for scanning the broken toucan's beak. Then they 3D printed a prosthesis for it. By the way, the same technique is used for the prosthetic fields of medicine. Okay. Artec team digitized fossilized prehistorical animals, working with the world-famous paleontologists. Here you can see a hominid being scanned by the spider scanner at the Lake Turkana, Kenya. The old Artec scanner MHT is still being used for the professional purposes. It was used for creation special effects for the movie Jurassic Park, and it was used for scanning Arnold Schwarzenegger for the Terminator Genesis movie some years ago. Sorry, nobody needs this sound. Well, our scanners were used for 3D scanning the ex-president of the United States, Barack Obama, to make the first ever presidential 3D portrait. Here you can see the result where they used 3D scanner for gaining rich geometry and photogrammetry for resulting in excellent texture. The project Artec Shapify booth was launched several years ago. So my talk is about the most recent feature for this project. Using this full body scanner, people can get scanned and receive a 3D model of their own body. And such 3D models can be animated or used as an avatar in their favorite games, or if they wish to save the special moment of their life, it can be even 3D printed. When installed, the booth looks like this. Booths are installed in several modes in some countries. The project evolved. It got lots of new features. We increased throughput of the booth by 4 times. We as well as increased the quality of the final model. Shortly before last New Year, I've heard about the new feature for this project, which called body measurement. The case is the Artec company was cooperating with the University of Luxembourg for the last 2 years, and they were working together on researching on how to get the body measurements based on the 3D model of human body. Such feature may be in demand in some fields of sports medicine or in the e-commerce. Now then, several weeks before the new year, they received the first good results, and we decided to launch this feature, to integrate this feature to the Boost project solution in alpha stage. It turns out it was only the tip of the iceberg, and the big journey with its ups and downs was waiting for me. Before my journey had started, I understand only that I have only 2 weeks. The beta stage of algorithms were in their beta stage. I had only 2 weeks before the deadline because we were going to present this feature at the biggest 3D event of the year called the CS conference in Las Vegas. Also, we expected quality assurance stage to be processed on the bigger amount of data. I wasn't certain about the point of integration, as well as I didn't know anything about the technological stack used for these calculations. So how to deal with that, you can ask me. Well, just do it. Beta stage of processing algorithms, it means that I should consider any fixes or improvements to be deployed. So deployment should be as easy as possible. Deadline in 2 weeks, well, it forces me to use the simple solution setup. So I didn't want to dig through an enormous amount of edge cases of the complex or extraordinary solution. Quality assurance stage to be processed means that that the deployment itself should be as easy as possible. Well, the obvious solution was to use Docker. I had only one problem left, is how to get access to the GPU from inside the container. The infrastructure began to emerge. I definitely sure that it is passive service with an API protected by HMAC. This service receives an API call, a request API for processing. Then external service starts asking for the status of processing, and in the end, it asks for the result. And of course, I need background workers to perform the actual processing. Who uses HMAC signatures for your API calls? Well, oh, okay, not so much.
Do GPT counts?
Oh?
Do GPT counts JSON Web Token?
Yeah, I think we can count it. Okay. So HMAC is a hash-based message authentication code involving a cryptographic hash key and cryptographic function and secret cryptographic key. We used it for 2 purposes. Firstly, we need to ensure the requester. We need to verify that we will use our hardware only for our needs and not for others. Secondly, it helps us to verify that we received all the content. ATAC services often use HMAC while interacting. So when you are dealing with the service architecture, what is the most common problem to solve? Who thinks it is the latency, especially during the heavy use? No one? Okay. What about service discoverability? No, guys, what's wrong with you? What kind of problems are you solving? Okay. Generally thinking, it is an interaction problem and services downtimes. So let's take a look at the pros and cons of the passive service. Here we have an external service demanding the data to be processed and the body measurement service which performs actual calculation. After the processing starts on the body measurement service, the external service starts asking for the status of body measurement, and when body measurements succeed with calculations, it asks for the result. compared it to active-active scheme, where the external service asks and initiates the processing on the body measurement service, and when it's ready, the body measurement service sends the results back to the external service. But what happens if the request fails? To make it clear, we need to repeat our request because not to left our clients waiting. Actually, in the real world, there is a huge and big queue between before our booth, and people are waiting for 30 minutes to get scanned. So in the real world, if the client doesn't receive its body measurements, it's really bad, and it is our fault, of course. So let's get back. Let's compare it to, So if the request fails, the external service must repeat it in some time. It means that the responsibility is lies on the external service. But compare it to the active-active solution. If request fails, if request for the processing fails, it means responsibility already lies on the external service. But if body measurement didn't succeed in posting the results, it means that it also has responsibility once it receives the data to be processed. So in this case, we double development, double support, and we increase the climatic complexity of our solution. Let's look through the benefits of the passive service. Firstly, we have only one side which is responsible for the fault tolerance. Secondly, we decrease risks of complex downtimes. And it is cheaper from the development perspective. So let's get back to our service. We have a passive service with an API protected by HMAC and background workers to perform the processing. After a few test runs on the quite similar hardware, I get a clear understanding that it takes 3 minutes to process one model. Also, I understood that I've seen that the process of calculation utilizes almost all the CPU available on this instance. And finally, it requires at least one GPU core to complete the processing. So if I don't want to see the increasing queue, if I want to deliver my results on time, the solution should be scalable. I'm going to show you the final body measurement infrastructure. Let's take a look. Firstly, we have a front instance which is responsible for the API calls. It saves some data to the database. It adds a job to the queue to be performed and sends metric about jobs. The scaling starts the instance with the GPU, where the worker container is launched on Upstart by using Ansible. Worker accesses the queue and takes the job to be performed. It prepares some data and then runs the processing container. Tasks for the background workers split into 2 groups. The first one is understandable and easy to develop tasks. So the development I'm not sure if it's working. Okay. The development, the measurement starts its processing. It downloads the data. It verifies the downloaded archive. It extracts data and finds the source model to pass it to the processing container. Then the processing happens. And then we clean some our directories and execute the finish method. The finish method consists of checking for the results, because we are treating the processing container as an external DSL. And then when we check that results are here, we update the state of processing. So in the case that we have a stale process, let's think about it a little bit. When we have stale processes, autoscaling see that there are jobs to be performed in the queue. It launches instances one by one, but processes are stalled. So our queue is still has as much jobs as it was before launching. So observing the increasing amount of the instances, we observing, and not decreasing queue length. It's bad. The most efficient way is to rely on the complex methods and limit the execution of some tasks. That's why here I limit on time the execution of processing, and if processing runs out of time, I just kill it and treat timeout error separately. Okay. The processing still looks like a black box. That's why I decided to take the black box paradigm as a basis. I submit enter data I expect for the specific results, and after I receive it, I save some logs, some additional debug information for future improvement of our processing algorithms. As well as dealing with the black box paradigm, I use the external DSL approach. I have a Docker container, a Docker engine as the object of the external DSL. And I wrapped the method run as an interface to my external DSL. That allowed me to divide responsibility zones and code of two different parts of my service. The worker container is responsible for the transportation, and it is supervisor. It controls the flow of the processing container of for the body measurement calculation. And the processing container, it doesn't run permanently. It just scales, it just runs from the image when we have a model to be processed, and then it just finish its life cycle as well as all the processing. So as I use the run of the Docker container as any other command line utility, I have some features for free. First of all, I use standard exit codes to monitor the process status. And then I use std_err and std_out to see the logs in real time. So I usually avoid risk of edge cases. That's why it sounds too complex to run the worker container on the host instance, to start the processing container from it, and expect the processing container to have access to the GPU. So I decided to run both containers on the host instance. How did I do it? Well, a little bit tricky. The processing container, I pass the Docker socket from the of the Docker engine from the host instance into the worker container. And the worker container, while he interacted with the Docker engine, it interacts actually with the Docker engine of the host instance. That's why I have an ability to launch one container from another container, but both on the host instance. Let's walk through other attributes of our containers. I use the KRM, but for the different purposes for each container. For the worker container, I use KRM because container is launched from the image by Ansible on Upstart. So if something happens to it, if something bad happens to it, it will be just relaunched from the image, and that's okay. But for the worker, for the processing container, I used RM key because I have only one container that does only one job, and new model to be processed means new run and new container. I don't need to keep them. So I use IK for interactive mode to access logs from the processing container in real time. As I launch the worker container from the processing container from worker container, but both on the host instance, I can't just share the directory with the source data from a worker container to the processing container because processing container is launched on the host instance. The directory is just not accessible. That's why I share the directory from the host instance to the worker container, and then share it still from the host instance, but to the processing container. And this make accessible the sources data for the processing container. So to perform background jobs, we are dealing with two containers. The processing container is being launched by the worker container. Worker container fully controls the flow of the processing container and can't just kill it if it runs out of time. We run both containers on the host instance. We share Docker circuit from the host instance to the worker container to make it accessible from the worker container, and to run both containers on the host instance. And yeah, it gives me access to the Docker socket and the Docker engine of the host instance from inside the worker container. Well, I was expected that it will work, but it doesn't work. My OpenGL context wasn't found in current thread. Surprise, surprise. Of course, I have to install drivers for the video card. As I use AWS software, hardware, especially P2X Large, I am dealing with NVIDIA and NVIDIA drivers. While Googling the information about the drivers itself, I ran into this post, and it makes me laugh. The guy was Googling for the solution, how can he run the game Quake 3 on his Linux laptop because NVIDIA CTL wasn't accessible. So that makes me calm, because it shows that problems with the drivers were every time, all the time, and that's okay. So I found that NVIDIA drivers should be installed on the host instance, but it is not enough. We need to install the same drivers into the container, operation system. The most helpful articles, by the way, were like how to build your own farm, and I really appreciate it. Moreover, they helped me to figure out that drivers should have the same version, because otherwise we can lose some of their API, or it can even crash. The same version of drivers wasn't enough. I still have a problem. My OpenGL context wasn't accessible. So it turns out we have to create device nodes. We create NVIDIA X. By the way, they range from NVIDIA 0 to NVIDIA X, where X is the number of GPU cores available. We create NVIDIA CTL to take control over the GPU, and NVIDIA UVM. It is unified virtual memory address space, which can be accessed by the CPU and GPU in a transparent way. So I share device nodes as the devices to the processing container. But to make them accessible, I need to share it firstly as a volume. Let's summarize. To access the GPU from the processing container, I have to create device nodes. NVIDIA X for each GPU core, NVIDIA device node for NVIDIA CTL, and NVIDIA UVM. Then I should share the devices, and I should share each device as a volume to make them accessible inside the container. And after that, I use device parameter for the run of the Docker container for each device node I have. While implementing this processing container, we thought how it would be good if we can use this processing container under the OS X or Windows to make for easier collaboration with our research development. But it turned out that it is not possible due to the due to the difference in virtualization. I will share some links on my last slide. Finally, it works on our debug instance. We were happy to finish our jobs. It was close to the new year, and we were happy and ready to open our champagne. We were starting our load testing. But then, holy dolly, I didn't believe my eyes. It had just worked, but it doesn't work right now. What happened? So the difference between this time and my debug instance were that here we have instances running on upscale, launched on autoscaling during my load testing. So it turned out I have to create device nodes each time on Upstart if they are missing. I used this script. Okay, we have no highlights, but I think that's okay. I have this one. Here I'm trying to add the NVIDIA module to the Linux kernel. If it succeeds, I'm counting the number of GPU cores available, and then creates the device node for each GPU core I found. Then I create a device node for NVIDIA CTL. But if it failed, it's just the script exits with non-zero exit code. The same is relevant for the NVIDIA UVM. I'm trying to add the NVIDIA UVM module to the Linux kernel, and if succeed, I create a device node for it. But if it fails, it just gets out of the script with non-zero exit code. So the body measurement feature ran successfully in pre-production mode. We finished load testing, and it was the most smooth and trouble-free release ever. Summarizing, to access the GPU from the Docker container, you need to take care of drivers first. You should install drivers on the host instance and into the container. It is vital to have the same version of the drivers on the host instance and inside the container. Otherwise, you may lose some of the API available. Secondly, you shouldn't forget about device nodes. Oh, sorry. You should create a device node for each GPU core available and for the NVIDIA CTL and NVIDIA UVM. Also, you should share them as a volume and pass as a device each time. You should share each node as a volume and pass as a device to the container. And finally, if you don't have device nodes on Upstart, you should create them before. Now you know as well as me what the benefits of the passive services are. How to launch the one container from the another container but run on the host instance both. What driver installation process contains. You know that there are a lot of useful articles on this subject, and you can Google it by how to build your own farm. You know that to have access to the GPU from inside the container, firstly you need to create device nodes and pass them to the container. You know that if device nodes missing on Upstart, you should create it. And I hope this knowledge will help you to deliver your features on time as well as I did. Thank you.
Thank you. Anna, thank you very much. So, folks, please raise your hands for questions. Okay, there is one was first.
Thank you for your talk. First question. You mentioned that it was CPU intensive, correct?
What? Sorry?
Your body measurement.
My body measurement.
Not yours, I mean service.
Okay.
Yeah, you used GPU to solve that problem. There's a lot of modified processors currently, from ASICs for mining to something like ARM restricted to simple instructions that do this kind of job quite with a good performance. Have you did some research on that?
No.
Okay.
We have 2 weeks before the deadline. Sorry, guys.
Yeah, okay.
AWS is our all.
Okay, thank you.
Okay.
Thank you for your talk. I'm here. Right.
Hi.
Here. Yeah. Hi. As I understood it right, if I understood it right, you use some cloud-based, maybe your hardware outside your booth. So you have booth to scan, and I want to understand the data process. So it just collects the data, and then you transport it some way to your processing hardware or cloud. And the main question: how much time does it take to get full 3D body model?
Okay. If I'm allowed, I'll take 2 minutes to explain the whole process.
Sure, go ahead.
Okay. So the person gets scanned on the booth installed somewhere. It has its own processor, and the first row calculations, the first line of calculation performs there, because the raw data weighs about 4 gigabytes. And as it is scanning, it's not renders, which can have a pretty good look in 3D model with several kilobytes. Now the scans always weight much, so we have the first line of processing just on the booth. Then it sends to our ATAC cloud, so-called also service-based solution, which does the second line of the processing. And when the cloud receives the pre-model, some raw data, they weight about 50 megabytes, so it's a big deal. Then the processing happens. It's also cloud-based solution, because we have Ruby and Rails as the front and some of the background jobs, but we have C++, C# as a wrapper, and Windows for the main processing part. Then it goes to the final service called Shcherbinina, because it's a Shcherbinina booth, and the service Shcherbinina booth receives the 3D model and prepares 3D displayable way of showing this model, and it's also microserviced. Then, and here we started, here is the entrance point for the body measurement processing, because we need the ready-made 3D model for these calculations. So the whole process takes about 40 minutes to deliver the final result and to show it to the client. But the first results of the first raw calculations is shown, I think, in 2 or 3 minutes, and it is enough to verify if the scan is succeed. Because when we are dealing with the scanning solutions, it's often you can't be certain for sure will scan be good or not, because it can have shiny objects, and this shininess is quite bad for us. So, okay.
Okay, thank you very much. There is another question.
Hello. For the first, thanks for the talk.
I don't see you, sorry.
Hello?
Stand up, please.
Yeah, I'm here.
Hi.
Hi. What were the reasons why you decided to use nested containers in the first place? Because it seems like you've been through a lot of hassle to set up this config?
The containers are easy to deploy. It's obvious.
So you think it worth it to expose GPU resource through to the first container and then to the next one? Yeah, just to have a more manageable services.
Yes, it is so.
Okay, thanks.
Okay, one more question here.
Thank you for your interesting talk, and I have a question about the final architecture slide that you shown.
Okay, we can switch.
If you can turn back,
Let me do like this.
just for the context.
Okay. Can I leave?
Oh,
Oh, you don't see it. And I see it. And you don't. Okay.
and the final part. Yep.
Okay.
Yeah, this.
Uh-huh.
I'm interested in what you say that worker container just load the data from the queue and prepare this for the processing container. But these containers have a different load profiles. And if you want to move faster with processing, you may want to scale up processing containers separately from the worker containers. Did you face such kind of problems? And how you would solve it, if yes?
I'm sorry, in my case, perhaps I wasn't not as understandable as I wanted to be. In my case, the whole flow of the processing container is controlled by worker container. So I need somebody to take control over the processing, because otherwise I'll have just uncontrollable something on my instance, and I don't know what to do with it. And in my case, I use the worker container, which does all unnecessary stuff, not related to actual calculations. And then it launched the processing container. The processing container runs with the one command, which is actually processing. And then when it finished, it just scales down. The container just finish its run.
Oh.
Did I explain? No. Okay, we can talk later.
Yeah. Thank you very much, Anna. Let's.
Thank you.